Hello again. We're going to continue our review of C++ by doing some exercises that only rely on skills we learned from the previous programming workshop. So, first, let's start working with some files. We're going to open a file, read some numbers inside, and compute the average of the prime numbers. So, let's get started. I can do this in a notebook, I think. IOStream, fstream, standard namespace, and the question. And go. Okay. So, write a function. Okay. It's going to not return anything because I don't see the words return anywhere. So this is a void function. I'm going to call this file parse because that's basically what it's doing. And the function is given a file name, which I suppose is a string. So now I need to open a file, read all the numbers inside, and compute the average of all the prime numbers in that file. So in order to open the file to read, I need an ifstream. And this is going to be my file.open. File name. Okay, so now my thing is open to read. Now, I can read in these files, and we're going to read them into an integer variable. So, num. And I want to read all of the numbers inside. But just to keep things simple, before I even do that, let's make sure I can read in one number and just print it out. And we'll worry about some other stuff after, but for now, I just want to make sure things are working okay. So let's just make this so that it can print out a single number. The new line. And I want to read from my file into num. Let's make a file. We'll call this nums.txt. And we'll put in some numbers. Okay. File parse nums.txt with quotes. Let's see what happens. It read in the 1. Okay, so things seem okay. Let's double check. We'll make this 100. Can we read in the 100? Yes, okay. So all is well so far. We're able to read in a number, but I want to read in all the numbers, which means I want to actually do this repeatedly. Pardon me. Now, when I read in a number, the operation of reading in will actually return a value equal to false if there are no more numbers to be read. So by saying while read in numbers, I will keep reading in the numbers. Now for each of these, if num is prime, and we'll figure out how to do this after, then I want to do two things. I want to add it to a growing sum, so I need my sum, and I need to count how many there are. So count plus plus, sum plus equals num. And at the end, I can print, instead of %d, I'll do %f. I think there's another one for doubles that isn't floats, but f is fine. And we will do, here, let's do float sum divided by count. I'm making this into a float because when I do the division, I don't want to do integer division. 5 divided by 2 does not give me a very satisfying answer, but 5.0 divided by 2 does. So I want this to be a floating point number, which means that I'm going to do the division correctly, and then I need to print out that floating point number at the end. Now, I need to figure out if a number is prime. How do I do that? Well, it's a very easy answer. We did it already. Last video exercise, we have this code that determines if something is prime or not. So I'm going to take all this and bring it over here. We're gonna make a little function called bool is prime, given a number. I think we called it pyvar. Bool is prime. Tab that over, and it will return is prime. Now that I have a function that determines if something is prime, I can say if is prime num, do the thing. All right, let's try it out. .25. How do I know if this is right? Well, I guess I can do the math. It seems fine. Prime, 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 prime. That's it, right? So this is 7 and 5 is 12, 15, 17, and 17 divided by 4, because there's 4 of them, 4.25. There we have it. Great. All right, one down. Let's move on. Okay. Sorting. So, write a function that sorts an array of strings into alphabetical order based on the last characters of each string. Now, you can kind of guess, just like before, we know how to do this problem because we did it already. So we'll use that to our advantage. So, back here, let's make exercise 2. Here's some stuff. And we also, from the introduction, wrote a little function handy here called which comes first, and we're going to use that. So here is my which comes first, which I know works from before. Oops, got to make sure I run everything in order. There we go. And now I can write a function that sorts an array into alphabetical order based on which comes first. So it sorts, doesn't return anything. We'll call it sort array because that's what it's doing. Let's say we're just working with an array of, well, yeah, it says we're working with an array of strings. And I need a number of how many strings there are. Okay, lots of different ways to sort. You can feel free to choose your favorite way to do it. I'm going to do a very, very basic one, which is I'm going to start off by assuming is sorted is false, while it's not sorted. I will then optimistically hope it is sorted, and then go through and find out if it is or not. For I is 0, I is less than the number of strings that I'm looking at. Basically, for each string, minus the last one, I want to compare which comes first. So if one of them is the one that comes, so if a given string is which one comes first of itself and the one after it, then everything is cool. You know, the first one comes before the second one. But if that's not true, then I need to make an adjustment, which is I need a temporary string, which will store the first one at index I. Index I will become the string after it, and the string after it will become the original I. Okay. Also, is sorted clearly is false. So there's my little sort. Did I miss a symbol? I think I missed a symbol somewhere. Maybe here? What am I missing? Could be that this is supposed to come over here. Is that right? Did I do that correctly? Yeah, put the brackets in the wrong spot. There we go. Okay, so string words it's hello, how are you? So by last letter, we should see that R comes first because it has the E, then hello, then you, then how. So let's see if this works. Sort array, words, there's 4 strings, then give me your words. Looks like I'm printing out a whole bunch of them, probably because we got some print statements over here, which I don't really want. They are very confusing to have. So we'll remove those print statements. And now we got what we wanted. E, O, U, W in order. Perfect. And this was so much easier only because we already had this function working. And this is an important part of things that we're going to do in this course, which is that if you have a function that solves a problem, use it whenever you can to solve trickier problems. Don't reinvent the wheel. If you know how to do something, use the code for it. This was actually, in some ways, not great because I had to write a whole sorting algorithm, whereas if you've already written a good one, use that instead. Don't bother using rewriting the whole thing from scratch. If you already have code that sorts, use that code. It will save you time. Okay, that was exercise 2. Let's move on. Exercise 3. Okay. Write a function that takes a pointer to a dynamic array and an integer size and resizes the array to the size. If the original array is smaller, copy over all the old elements. The original array is bigger, only copy over the first one. So we're doing some resizing. Okay, yes, 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 keep going. Okay, that sounds good to me. So, it does not seem to return anything. We'll call this resize. It's going to take a pointer to a dynamic array. We'll assume it's integers. So a pointer to my array, which was done dynamically, and a integer size. Now, in order to copy over all the old elements to the new array, I need to also have another parameter, which was an integer old size. Because otherwise, how do I know how many to copy over? Or actually, hold up, do I want to do this? Yeah, I need to know what the original size was. Because otherwise, there's no way to figure out how many to copy over. Yeah, okay, so in either case, I want to have a pointer to my new array. This is going to be new integer dynamic array of size elements. Okay, so there's my newly created dynamic memory. Now I need to copy stuff over. So if old size is less than the size, then copy over everything. New array I is my original array I. Otherwise, I want to copy over the first size elements. So same thing, except I'm going to use size. Now, what's left to do? If I leave this as it is, it's not wrong in the sense of it will do what I want, except nothing will really happen because I haven't bothered to update this pointer to point to the newly allocated dynamic memory, which means I need to have my old pointer point to my new array. But now there is a problem, which is a memory leak. All of my old data is still sitting in the computer, and after I run this line of code, I have no way to access it. So before I do, I need to delete all of this old memory. And there we have it. So to make sure this works, let's make some dynamic memory. So int nums equals new int, let's say 5 numbers. Nums I is num let's say I plus 100, just for fun. Oops. Yeah, I guess it makes sense. It's a pointer. It's just going to give me an address, but we can output nums I. And so here is our dynamic array. And let's say I want to resize this to just a size of 3. Let me split this part up, the printing and the assigning. Okay. So let's say I resize nums the original size was 5, and let's say the new size is 3. Let's see what happens. So what's happening? Well, my did this do what I want? No, it didn't. And we can talk about why as well. When I resize this, I move this pointer over, but none of this is actually reflected in what's going on back before, because I did not pass this pointer by reference. So in order to make sure that I'm actually modifying anything, I need to have an asterisk in here so that my data, my array pointer being modified actually gets modified down below. And there we go, I got my 100, 101, 102. These last are just sort of junk values because I told it to print out 5 numbers, but there's only 3 numbers left in my array. The other ones are gone. Now what happens if I decide I want to resize it to a size of 10? Once again, we got a bunch of junk values because I haven't assigned them there, but they are all part of my number array. And so I can assign those to be what I want. So let's say I decide that, nums 6, or it's like nums 5 is 999, just for fun. Now you can see that 999 has gone into place. And there we go. We have our resizing function. Important to pass our pointer by reference. Otherwise, when we try to readjust it, nothing is going to do anything. And it's going to either increase or decrease the size of our array as we choose. Okay, on to the last one. Final exercise. Let's take a look. Classes and vectors, and we're going to work with a lot more classes this semester, but let's just do this simple example. Create a class that represents a set of integers. The set class should only have a vector of data as its only attribute, and the set class should have a method to add, which only adds a new element if it doesn't already exist, to delete, and to print out the contents of the set. So this one I will not make in a, I suppose I can make it in a notebook. It's simple enough. Plus, okay, exercise 4. All right, include iostream using the standard namespace. Here is our problem. Oh, I also need to include vector, so I'm going to have a vector. Okay, so I'm going to have a class called set. And in here, I need to have a vector of its data. So this is a vector of integers, which we'll call data. We need a method to add, given a number. We need a method to delete. We'll call it del, given a number. And a method called print, which doesn't need anything. Now we need to implement these. So set, so void add int n, but not just a generic method. This belongs to the set class. We need to add a new element to our data, but set is defined such as a collection of items where each one is unique. You never have 2 elements in a set that are the same, because otherwise it wouldn't be a set, it would be something else. So in order to add something in the data, I first need to for each element in the data. If it's already there, then I will do nothing. Otherwise, I will say data.pushback the number. So if I go through and there's already a number there, fine. I don't need to add a new element to an existing set if I already have that element there. But if that element doesn't show up in the entire set, then I need to put it in. Now I also want a method to delete and now I need to actually go through my vector, find out where there is a number, and then remove it. Now, to do this is a little bit trickier because I need to actually use the remove function from a vector. And that means that I'm going to need to, so let's see, I need a vector int iterator I1 is data.begin. I1 is less than data.end, I1 plus plus. And the reason I need an iterator here is because I want to have a pointer that's going to point through the vector until I find what I'm looking for. And if I1 is pointing to n, then I will remove I1. And then finally, the easiest one, print for each number in the data, print it out. Okay. I think it may be unhappy with me putting all this into one cell, so we'll break this up. So here's my class, here's add, here's delete. Oh, sorry, not remove, it's erase. Erase is the name of it. Oh, it's not overloaded, it's just data.erase. Okay, now let's see if this works. So, set s dot add 1, 2, 3, and 1 again, and then print. Notice it only added 1, 2, 3 because 1 was already in the set. I don't need to add it again. How about s.del to s.print? There we go. We removed 2, and now we just have 1 and 3. And I can do add some more values. And you can see it's only ever going to have unique numbers inside of it, which is the whole point of our set. And there we have it, our little set class that does the things we need a set to do, and lets us make sure that we have done it correctly. So that's it. This is our recap of stuff from 1060, and from this point on, we're moving forward into new territory. So we'll be exploring it together. Excited. Hope to see you there. Bye-bye.